Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper trending on X, published on August 13, 2025, just 2 days ago. The standout result is simple but powerful. By sampling more during training and filtering by length or token efficiency, the method keeps accuracy while slashing length inflation by roughly half to more than 80% across tough benchmarks. The paper is titled, Sample More to Think Less, Group Filtered Policy Optimization for Concise Reasoning. And as we will see later, the implications for model training are quite significant. In short, longer is not always better, and careful filtering teaches concise reasoning. Building on that, tweets highlight a simple fix. Sample more during training, filter by shortest or most efficient responses, cutting length by roughly 70 to 80% while matching accuracy. Engagement looks solid. Alright, this figure has two parts. On the left, the method tweaks standard group relative policy optimization by sampling a bigger set, ranking by a metric like length or token efficiency, then learning only from the top K, which effectively zeroes out gradients for the rest. Moving to the right plot, you see response length over training steps. Baseline balloons past 14,000 tokens, while token efficiency filtering stays near 4,000 to 6,000, and the adaptive difficulty variant lands in between, showing strong length control with reasoning intact. Next, focus on this two-panel chart comparing training accuracy on AIME 25. The overview shows accuracy versus training steps, with lines for the baseline and several filtered variants. On the left panel, the shortest 8 of 16 and shortest 8 of 24 tracks climb alongside the baseline, reaching similar peaks. On the right panel, token efficiency and the adaptive difficulty strategy likewise meet the same top accuracy, though token efficiency wiggles more, indicating higher variance while still converging competitively. Now, this table summarizes accuracy, average length, and length inflation reduction across AIME 25, AIME 24, and GPQA. The key pattern is clear. Several filtered settings keep accuracy near the baseline, while shrinking responses. Shortest 8 of 16 and 8 of 24 already cut excess length by about 30 to 50%. Token efficiency goes further, showing about 85% reduction on AIME 24 and nearly 80% on GPQA. The adaptive difficulty setup balances cuts with top accuracy on GPQA. Continuing the results, this table compares settings across Omni-MATH, LiveCodeBench, and the overall average. The key takeaway is steady accuracy with much shorter responses. Please focus on the table body showing rows like 6 of 16 and token efficiency. Shortest 8 of 16 trims length inflation by around 30 to 50% on average, while token efficiency delivers about 80% reduction with similar accuracy. Adaptive difficulty also cuts length strongly and posts the top average accuracy, showing a balanced compute and concision trade-off. Here, each panel plots accuracy on the vertical axis against response length on the horizontal axis, with the green region marking points that beat the baseline in both metrics. Notice the clusters. Several filtered variants land up and to the left of the baseline, meaning shorter and at least as accurate. Building on the earlier tables, shortest 4 of 24 and shortest 8 of 16 consistently sit in that green zone, while token efficiency hovers close with slightly more variance. The average panel confirms the overall Pareto edge. Building on that, two takeaways stand out. First, sampling bigger groups during training and filtering by shortest or by token efficiency, meaning reward per token, consistently preserves accuracy while slashing bloated chains, often by around 70 to 80%. Second, the adaptive difficulty variant smartly spins compute on harder questions, keeping concision without sacrificing correctness. Thanks for tuning in. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.